That's why they don't go to their job. They get paid like $10 an hour.
Trying to get
so
to the
nice.
public.
Do they have good cakes there?
Yeah, they also have really good benefits and they give a ton of raises and promotions all the time.
That's
so-
good.
Yummy.
I worked retail.
I was gonna work in a warehouse, but
Back in
I
the
can't because there's heavy machinery in the back. So
Uh-huh.
Tutoring and babysitting are your gigs you need to do for some good, easy money. Tutoring and babysitting.
I'm afraid the kids wouldn't like make it back the same. That's
Then
why.
tutoring is probably best for you.
I would just do tutoring.
Take
Give them
care.
to-
Okay, so 7-4. Like I said, what we learned on Friday and what we're learning today is helping us for what we're doing on Wednesday. Okay. So here are our logarithmic properties. Okay. We are gonna go left to right, and we're also gonna go right to left with these properties. So you want to make sure you have these down.
Are you recording
I am. Thank you.
it? Okay.
Yeah, it's hidden down here in the bottom. You can't see it.
No, actually, I'm not recording this one.
You got it covered, man.
She did. Where she said no.
Okay, so remember your exponent properties, okay? If you are if you're multiplying with the same base, you added your exponents, right? When you were dividing with the same base, you subtracted your exponents, all right? Logarithms, they're the inverse of exponents, so they're gonna have the same properties. If I'm multiplying two things inside of a logarithm, I can expand it using addition. If I'm dividing, I can expand it with subtraction. The only one you probably haven't seen before, if you have an exponent, we're going to move it to the front. Okay? So these are the three properties we're going to go forwards and backwards using. All right? Expanding is not going to be something that's going to help us with solving, but condensing is, okay? But in order to understand condensing, we're going to do expanding first, okay? So we're going to expand first, and then we're going to condense, and hopefully it'll be a lot easier for you. This is definitely different, and it's sometimes hard for people to grasp, so we're going to try and take it as slow as we can, but hopefully y'all will catch on.
Was your 7 a.m. more engaged because I got an extra hour or something?
They're a little bit more awake.
I hate doing saving time.
What? Why?
What's the point, you know?
To save time.
Yeah,
It's more of a harvesting thing.
For farmers.
Sunrise and sunset, make it more.
I think we need a calendar.
What?
We don't necessarily, not majority of us don't live in that world, so we don't understand that time change. But for those who do,
I'm home.
It's a big
so
deal.
I don't know what to talk.
I'm on the sundial.
My parents send me here to keep me in the loop. You know, 'cause they don't want me to be left out, but they also want me to be part
I'm
of
pretty sure
it.
that's the exact, like,
I
point
built this
of
phone
being
out.
on me.
Yeah, I have a
I
sundial
built
watch.
this phone out of wood.
okay. So down here in red, it said rules apply when the base is the same. The base has to be the same. Okay. All rules also apply to natural logs. Okay. So those are those LN. Let me scroll up just a little bit so people in the back can see. So rules only apply where the base is the same. And all rules apply to natural logs as well. Okay. We're going to be using these properties to first learn how to expand, and then that's going to help us with condensing. Yes.
What is a natural log? Again, I need you to tell me so I can remember this.
It's the
It's that
log with
Ellen.
an E at the bottom.
Has a common logarithm of a base E.
Okay,
Okay. So like instead of this example here,
Yeah,
I could put ln of x to the y. It's the same thing. I would just get y natural log of x. That's what they're saying. Instead of literally writing log, ln, and it's the same property. Okay. All right, so let's look at our first example. I gotta give myself some space here. Okay, let's look at number 1. So because I have an exponent outside the big set of parentheses, I'm going to deal with that one first. You could apply the exponent to both pieces inside. That's one route you can take. Or we can start off with our properties, and I'm going to bring that 2 to the front. So right now I just have 2 log base 3 of 12 over 7 cubed. I understand that y'all are going to get to a point where you can do all of this in one step. I get that. Be careful if you get that confident, okay? And the only reason why I say that, if you do it all in one step, just make sure that you're right, I guess is the best way to put it. If you try to do too much at once, you can get all jumbled up. All right, look inside the parentheses. What's the big operation that's happening there? Division. How do we separate division? Subtraction, okay? So we're just going to continue to expand this. I'm going to use parentheses. So log base 3 of 12 minus log base 3 of 7 cubed. And the last thing I notice is that I still have an exponent. None of your final answers should have an exponent. I'm going to bring this 3 to the front of the log it applies to. It's not being applied to both pieces, so I only bring it to the logarithm that it actually goes with. So I get 2 log base 3 of 12 minus 3 log base 3 of 7. And my final last step is to multiply that 2 to the front of both logarithms. So 2 log base 3 of 12 minus 6 log base 3 of 7. That is your final answer. So it's weird when we're expanding, but trust me, to learn condensing, it's easier to expand first and then condense. Okay. Did I show a lot of the steps there? Absolutely. Do you have to show all those when we get down to this? Not necessarily. Okay. But for note's sake, I want to make sure you understand what's going on here. Now let's look at number 2. Not as involved. I don't have an exponent outside the big set of parentheses. So I can go ahead and start with inside the parentheses. What big operation is happening there? Multiplication. How do I expand multiplication? Addition. So now I have log base 8 of 5 to the 4th plus log base 8 of 7 cubed. And what would be my last step here? Jenna?
Put the exponents from the logs.
Put the exponents in front of the logs that they apply to. So 4 times log base 8 of 5 plus 3 times log base 8 of 7. Nothing's being multiplied, nothing's being raised to a power, and nothing's being divided, so I have completely expanded that out. That's weird, I know. It's new. Any questions so far? Am I going too fast? Okay, let's try 2 more of those. Oops, hold on. I accidentally covered them up now. Let me get this fixed here. So we have 3. For some reason, I didn't give myself enough space with these, so that's why I'm having to do this. And since I'm recording it, I was using the whiteboard in the other class. Okay, go ahead and try 3 and 4. 3 and 4. And that's the 6. There we go. All right, who wants to walk me through number 3? Let me get this scrolled down here. Who wants to walk me through number 3? Okay, go ahead.
So you can move the outside exponent to the front of the log.
Okay.
So
All right.
since you're dividing, you'd expand it to subtraction.
Okay. Don't forget parentheses after you're expanding it to subtraction. Hopefully, let's see if it'll let me. Yeah. Okay.
And then you move the exponent on the A to the front of the log it's going to.
Okay. And then what do you get once you distribute?
It'd be 18 log base 6 A minus 6 log base 6.
Awesome. Okay. So we skipped a step just because of space. I didn't have enough space to write it down. But if we bring this 3 to the front of the log that it applies to over here, and then distribute our 6, we get our final answer. So that's what I was saying. If you wanted to, a cubed over b that was the original, right? I think. If you wanted to at the beginning, go ahead and distribute that. Oh, I had to sneeze. Oh, I lost it. Okay. God, that's the worst when you lose a sneeze. You could go ahead and distribute, if you will, or apply that 6 to each exponent at the beginning. So then you don't have to worry about parentheses. But you just have to remember your exponent properties to be able to do that at the beginning, okay? So if you want to do that at the beginning, go for it, because then from there, you'll end up with the same answer, okay? So it's up to y'all. Okay, let's look at number 4. Who wants to talk me through number 4? Okay.
So you can expand it out to, you can move the, oh yeah, you need to move the 3 in front of the log base 4 first.
Okay.
Then you can expand out the u to the 4th times b to 3 log base 4 is it? Log base 4 u to the 4th times plus b or log base 4.
That?
Yeah.
Okay. Then what?
Then you can move the 4 behind the 4 in front of the log base and then just distribute the 3.
It's really tricky to write U's and V's, let alone with a 4 involved. Like, I start writing all kinds of things. So we should get 12 log base 4 of U plus 3 log base 4 of B. Okay? Questions so far? So, in chapter 6, I told you we would learn something that would help us in chapter 7. Okay, and that's when we were changing radicals to rational exponents and rational exponents to radicals. Okay, so same thing. When we're looking at number 5, oh man, where did that go? When we see the cubed root of a times b times c, we're going to change that to log base 6 of a times b times c raised to what? 1/3. Okay? So remember, cubed root is 1/3, square root is 1/2. Okay? So go ahead and try 5, 6, 7, and 8. All right, so if I finish, I'll finish out, number 5. If I bring that 1/3 to the front, I also know I'm multiplying. So I'm just gonna add. It's a lot of writing, but not hard to do, okay? And then I'm gonna distribute my 1/3 all the way through. That's the end of number 5. Okay. Someone different talk me through number 6. Number 6. Yeah.
You expand to 1 base 4 times 12, right, times 12 to the 5th, plus 1 base 4, 7 to the 6th.
Okay.
And then you take the 5 and you put it to the 5 and you take the 6. Next.
Whoops. Is that it? Okay, cool. All right, what about number 7? Let me scroll up if some of y'all are still looking at that one. Number 7. One different.
Yeah.
Number 7. Anybody? Okay,
I moved the 6 in front of the log,
okay,
and then I separated it to 6 log 8 x plus log 8 y raised to the second power. And then I moved the 6, distributed the 6 and moved the 2 in front of log 8y.
okay. Did it all in one step? Works for me. Is that what you got? Cool, good job. Okay, and lastly, number 8. Number 8. Is your left arm starting to hurt? Is your left arm starting to hurt?
I don't really know. Yeah, keep putting
Is it a
I do that
workout?
every
A little
time she's
disco
looking- I
workout?
do that every time she's looking for somebody to like answer a question. I'm always pointing you down.
He will raise his hand when he's ready. Anybody number 8? You already answered one. Appreciate
Yeah,
you, though.
dang.
Wait, you're gonna do it?
No.
Oh, okay, cool. Number 8. Who wants to do number 8?
It's almost out of defiance now.
That's fine. Because it's not towards me, it's towards Jonah.
Kind of.
Oh, okay, cool.
I mean, I don't really have a problem with you or him.
Oh, good to know.
Who's your problem?
Number 8.
You wanna find out?
It's between y'all and a break. Number 8. Yeah.
I think it might be wrong.
I'll steer you another way if it is. Go ahead.
The first thing I did is
Hey guys.
I multiplied the rational by 1/3.
Okay, you raise it to the 1/3. Okay. Okay.
And then I think I did it wrong now. I'm looking at it. I just kind of multiplied. I did like w times v times v, but I think that might be wrong.
Okay, so then let's work from here. What's happening between W and all of this stuff?
You're distributing w.
Not, but what is distributing? Is it adding, subtracting, multiplying, dividing?
Multiplying.
So how do you expand multiplication?
Add them.
So then I'm going to do that next. So if I have W,
And then those are adding 2.
okay, good.
Oh, and you're supposed to move the 1/3 over.
I'll do that. So it goes to both of them?
Yes.
Cool. See, even if you think you got it wrong, I'll walk you through it. That's what I'm here for. Those of you who can't see it, there's a V off to the side. So log base 7 of W. W is not in the cubed root, so this does not get a 1/3 with it. But since we're still multiplying all of those through, we're still adding when we expand them. Then we bring the 1/3 to the front of the U and the V, and we have our expanded version of this logarithm. So I hope if expanding helps, because we're going to condense here in a second. So let's go ahead and take a break, and then we're going to condense.
What are you giggling at?
The V looks like he's going like this. It sounds like he's going.
Yeah.
I don't know why it's funny. Just imagine some dude like.
Yeah.
That's it.
Maybe doing like.
I thought it was something
Yeah.
upset.
It's all like a 45-degree. So it's about to say that. Like Michael Jackson.
Okay, so let's go ahead and finish this by going backwards now. We're going to condense into one logarithm. This is what we need to know. Okay, so I'm going to show you an example at the end of the lesson today of why we've learned around the world and why we've learned what we learned today, because it's going to help us with solving. Okay, so condensing means I want one logarithm in the end. That's it. I don't want multiples, I just want one. Okay, so naturally, when I see that there are numbers in the front, if I'm going backwards, I'm going to think these come back up as exponents. Okay, so if I see a number in front, to me that means I need to pull that back up as an exponent. Okay, so then I look at the two logarithms and I realize that we are subtracting in between. So how do we condense that? Division. So I am totally fine with y'all leaving it this way. Some of us want to take it a step further and write log base 8 of a to the 6th over b squared. If you want to do that, that's fine too. I'll accept both answers. Either one of them are more right than the other, unless you're on a state test and you see one or the other.
Which one's more likely to be right if we see both of them?
One on the right,
How do you know?
because the fully simplified.
I would say, I guess I would say the one on the right. Only because, but at the same time too, I don't know. I mean,
Well, yeah, no, I'm not asking
Right.
for an answer, but it's just.
I can also see them
Don't assume.
accepting both if it was like a fill in the blank kind of thing. But those people make a lot more money than I do. And they make more mistakes than I do. All right, so the next one. I have my exponents down. I need to bring them back up.
Okay.
And since I'm adding, I'm going to do what? I'm sorry? Multiply. So like I said, you're going to get to the point where you're going to want to do a lot of these in one step, which is totally fine. Just be super careful and very confident in how you're writing your answer. Now, if you want to write this one as log base 2 of u times b cubed squared, that's fine too. Okay, I'll accept both. So hopefully by expanding, now condensing isn't too hard, okay? And condensing is the one that we need to know how to do for solving. Any questions so far? The next problem, need to get this. How do I get that? There we go. This is how the program writes their fractions. Okay, I'll leave that up there in case some people are still writing it down. This is how they write their fractions. So this is just the same thing as log base 9 of 11 plus 1/2 log base 9 of 3 plus 1/2 log base 9 of 5. Okay, that's just how this program writes their fractions. Okay, so go ahead and try 14. Go ahead and condense that. One half as an exponent means what? Square root. Okay. You will need to change it to a square root. Okay, so like I said, the 1/2 are going to be our exponents. There we go. So log base 9 of 11 plus log base 9. I'm going to go ahead and change this to the square root of 3. And log base 9 of the square root of 5. So if we're adding between all of these, we got to remember our properties from the last chapter. Okay, so if we have log base 9 of 11, then times the square root of 15. Okay, so remember, we can multiply the 3 times 5 inside the radical. Okay, only adding and subtracting was picky. All right. Questions? Okay. Let's go ahead and knock out 15 and 16. Again, that's just their way of saying 1/3 in front. My,
My dad's not.
my aunt had it 3 times. So that's the only one I got on it, that's it. It's lost its taste. I think I was 25. All right, does someone new want to walk me through 15? It's really getting into jazzercise. Someone new for 15.
Yeah, Joe.
Already done it.
He's already done one.
Do it again.
Okay.
Nope, someone new.
Your petty threats mean nothing to me, Daniel.
Petty threats. How do we do it?
Number 15. It'd be really neat if you didn't have any homework on Tuesday. When you have the day off, you can knock it out.
I'll do it.
New person.
I'll do it. I don't know.
Okay, it's just, we've got 15 and 16. So
I'll do
they're
it.
both up for grabs. Oh, battle it out. Who wants it?
Kate does, Kate does. Kate really wants it, Kate really wants
Do either one of y'all have a preference over talking through 15 or 16?
it.
Okay. Ladies first. Tell me about 15.
You move the 5 and the 30.
Okay.
And
Oh, did you say and the 30? Okay.
And then it's division, so it's log is to, a to the 5th over q to the 5th.
Cool. Awesome. Katie?
So I, log base 8, and then, parentheses,
Oh, you went ahead. Okay.
I just,
You did it all in one?
yeah,
Bold. I like it. Here we go.
C, and then the cube root of, AB.
Does anyone need me to work that out in pieces? We brought the 1/3 up as an exponent. 1/3 as an exponent is the cubed root. Okay. So if I had log base 8 of C plus log base 8 of the cubed root of A and log base 8 of the cubed root of B. And then when I multiply those together, since they have the same index, I can multiply them inside.
For number 14, like the one above, I just have a question that we can answer.
Uh-huh.
Will you accept it if it's, I mean, at least not for that one, if inside the square root, like if we had left it 3 times 5, would you take that?
You'd miss like maybe like a half a point or something
Well, I'm
like that.
just saying, like, because if there's like a huge number, we don't have a calculator, and there's like no point.
Yeah, I
I
mean,
don't wanna do that.
any number is really possible. You just have to go back to old school math and multiply it out to the side kind of thing.
Yeah, that's the problem.
Just do it on your phone. Oh, wait, no, he's Amish, remember?
Yeah.
Interesting. I mean, the expectation is that you would multiply them together.
Raisin freshly baked bread.
I think if, like, for instance, our end game, the state test, if it's a time test and they're just wanting to see if you understand a skill, I don't think on a non-calculator portion, they're going to give you bigger numbers like that because they're more so, I mean, I'd assume,
I'd hope.
but because it's not, hey, do you know elementary school math? It's, do you know logarithms? But I could be wrong. Okay, any other questions on those? So let me show you what I mean here by everything we've learned Friday and today, and why that's important, okay? What we're gonna come across is something like that. And we're gonna have to solve for x, okay? So we've learned how to make it into one logarithm. Why would we want to make it into one logarithm? Because then I can do around the world. So we've learned now, hey, if I've got multiple logs, I'm going to condense it down to one logarithm. Then I can go around the world. Log disappears, I can solve for x. Okay? So I can condense this. And then I can go around the world. So 3 squared gets me 4x, logarithm's gone, okay? So then my answer would just be 9/4. So that's why we've learned the around the world part first. Now we've learned expanding and condensing. Like I said, expanding is not going to help us because we want it down to one logarithm. But in order to understand condensing, we had to do expanding. And then we'll be able to solve from there. So it's kind of nice how that works out, right? Any questions? Okay, let's go ahead and get started on that work.